Dr. You are mute.
Department of Management. Am I audible? Dr. Firdaus, am I audible?
Yes, please go ahead. You are audible.
Yeah. Good evening to everyone present here. I, Dr. Shahid Amin, Associate Professor at the Department of Management, ITM Gwalior, warmly welcome all the participants, professors, scholars, and esteemed guests to the Day 7 Applied SEM Workshop Series organized under the aegis of JK Economic Association. Today's session is titled Applied SEM Model Building, Reporting and Interpretation, a crucial component for the researchers engaged in quantitative analysis, structure modeling, and advanced research. Dear friends, structural evaluation modeling has become an indispensable tool across disciplines, and today's discussion will help us strengthen both our critical understanding and application of SEM. It is my privilege to introduce our distinguished resource person, Dr. Mohammed, respected. We welcome you, Dr. Maroof, Professor and Dean Academics with Asian School of Business, Noida.
I think Dr. Shahid is having bad connection, so we are unable to, trace him where he is. So I request Professor Maroof, please go ahead with your session. I have given you these rights to share. Thank you.
Yeah,
Thank you, Dr. Firdaus.
Dr. Shahid, as your internet connection is very bad, so we are now going to start. So you can correct your,
Yeah,
connection
please.
at the end. You can give your concluding remarks. Please, Dr. Maroof.
Fine.
Okay, good evening, everyone. Thank you, Dr. Firdaus, and all the participants. So I'm sure I want this to be more of interaction because the major part is already done. I'm sure that you are through with you practiced the SEM, and I'm sure with the data also, and you have models with you now by now, and we'll try to discuss in terms of the results today, because that is the session all about, and try to understand that how do we actually present the result in the research papers so that the acceptance of the papers becomes better, because ultimately it's important that the publication is in the good journals, and I'm sure that is the target of all of the participants. Can somebody give me thumbs up if I am clearly audible?
Yes, you are. Please go ahead.
Okay, thank you. Okay, thank you. So what we'll do is we'll try to just have a look at a sample model and try to understand what all we need to actually mention in our paper. So I will just show you one of the sample models, and I will be sharing the data file also with Dr. Firdaus after this session so that you can also try this model. Is this screen visible to everyone, this particular model?
Yes, sir.
Okay, fine. So this is one of the sample models. Now, in this model, we have two things majorly. One is this outer model, right? you see you know these blue ones are the constructs, the main constructs, right? And and if you see these arrows and this outer model, right, which we call as the measurement model, and this inner one is called the structural model. I'm sure, yes, so you have idea about this? Yes, anyone? What are these yellow ones? I want this to be a little interactive because you have done all the analysis till now. See,
So
these are the
these
items, right?
yellow ones are the item of the
Okay.
construct.
Wonderful, wonderful, Shilpi ma'am. So these are the items, right? And the blue ones are the constructs, right? So the linkages between the constructs, which you see these arrows going from one to another, this is your structural model, right? The main model. And these items, they they make the what we call the measurement model. Okay. So just one second. Give me a second. I hope this is visible. The model is visible.
Yes, it is visible.
Okay. Okay. So I just wanted to be sure that the camera does not take the internet connectivity. Okay. So this model, what we need to do is that we need to test all these things, like the outer model, which we call as the measurement model, right? And the inner model, which we call the construct, right? The structural model. Now, these are majorly the two things that we need to test. Now, if you see the measurement model, there are two ways these arrows going, right? One is going towards the construct, and for few of the constructs, it is coming out of the construct. Any idea what the difference? You can write in the chat also if you don't want to speak. Yes. What is the difference? Yes, anyone? What is the difference between these arrows? Like for some of the constructs, the arrow is going towards the construct, and for some of them, it's coming out of the construct.
So they are showing the causal relationship between the two, uh, and in the cases when arrows are going towards the construct, it shows the items are causing the construct, and in cases where the arrows are going from construct to the items, the construct is causing the item.
Okay, so what do we call them? We call it, like, when the arrows are going towards the construct, we call it reflective, right? Or formative.
Formative.
Yes, because they form the construct. When when the arrows, when the items, the arrows are going towards the construct, we say that they form the construct, right? And why I'm discussing this is because we need to see what do we actually test here. Like when it comes to reflective means that, like in this case, COMP, right? So these items 1, 2, 3, they're reflective, right? And these items, like quality of quality service 1, 2, 3, 4, 5 till 8, this is the formative. Now, when you will have to define whether the constructs are formative or reflective. Now, what do we expect? Like in case of the reflective model, right? In case of the reflective model, what do we do is we need to see there has to be strong correlation between the items. And that's why we do something called a reliability test, the first test. You getting this? I repeat, in case of the reflective model, these models where the arrows are coming out, what we do is we need to ensure that there is strong correlation between the items. So we do what we call as the reliability test, right? So because unless all these the items are strongly correlated, so we cannot for sure say that this particular model is good to go ahead. Now, the opposite is true in case of the formative. Now, in case of formative, we need to ensure that there is we don't talk about the correlation between the items, because these items define the construct. Are you getting it? In case of the formative one, these items they will make the construct, which means that we don't talk about correlation between these items, right? In this case, rather there should not be correlation between these items, otherwise there is no need of having so many items. But another important thing about the formative is that in case of formative, we need to take all the possible items which can form the construct, because it is important that whatever way we can measure the formative this construct, we should take all such items. Okay, so that is why if you see, we'll discuss the papers. When you see papers, in case of formative, you won't find reliability test. Whereas in case of reflective, the first test to be done is the reliability test, and that Cronbach alpha should be at least 0.6. So we talk about correlation in case of reflective, not in case of formative, right? So this is one. Now, so we will have to test. There could be a model. Your model may have all the constructs which are formative. You may have in your model all the constructs which are reflective, or you may have mixed. So that's why I have shown you one model which has mixed, so that we can do both the things, right? Okay, so this is one. So this is what is measurement model testing. Is it clear? So measurement model, outer model testing would be done for two different models, right? These arrows. One would be reflective, going out of the construct, and the other one would be formative, which are going towards formative because they form the construct. So we will have different tests for these different types of models in case of measurement model. And then next we would talk about the structural model, which is all about the constructs, the relationship between the constructs. Is it clear? Now, what does the arrow indicate which goes from one construct to another construct? So this is nothing but the dependent variable and the independent variable, right? So that's what it is all about. Now, just brief about the construct ones, the structural model is you see a lot of arrows which are coming, through, like for example, we have this performance to this COPM, and then an arrow goes from this to this. So we need to see the loading, etc. But before we go to the papers, let's try to briefly see what is the requirement of each of these tests. Okay. Is it any doubt till now? I said, I repeat, there are two models which we have to actually measure. One is measurement model, where we need to see the relationships. The second one is the structural model. Measurement model has two different models. One is the reflective, the other one is formative. We may have our model on all the constructs may be formative, all the constructs may be reflective, or there may be mix. So if they are mixed, so you will have to test them individually. Okay. Okay. Now, before we go to measurement model, there is a common bias which is called as common method bias. Now, we will have to test this also, though at times the papers may not ask you, the journals may not ask you, but it is always advised that we do this common bias test. Now, what does common method bias mean? See, what happens is that let's say you have four constructs, and if all those four constructs you are using same scale, let's say you're using 5 point Likert scale or 7 point Likert scale in all of these, there are chances that because you are following the same scale in all those constructs, the the respondent may give you biased answers. So it's quite possible that the respondent may get confused, and respondent may give you the biased answers. Like you have one construct, right? Maybe on service quality, another construct you have two, three, or four constructs, and each of these construct you have different items, so different questions, right? Now those questions of different items you may get similar response because of the method, because since you are using same 5 point scale, so that may be the reason of this bias. So we'll have to test that also if it is there. Now, what we do is it is advised that if we want to avoid this, what we can do is we can have different types of scales, right? In different construct, like we can have 5 point scale, or we can have 7 point scale in some cases, we can have 3 point scale in some cases, so that we can avoid it. Second thing what we can do is when we talk about we avoid common method biases, that we should firstly that we should avoid naming the particular construct. Like the respondent should never get to know that what are you trying to measure, because then there would be obviously biasness. One, which this too we should never do, that we should never name it what actually we are measuring. So if we are measuring service quality, we should not name that as service quality. If we are measuring performance, we should not name it in the questionnaire as performance. Otherwise, there are chances of biasness. This is one. Second is, what we can do is that we can have different types of scales, right? So when we have different types of scales, so there are chances, because the moment one respondent shifts from one construct to another construct, so different questions, since they have different scales, so obviously he or she will think that yes, this is a different question, so obviously it can be avoided. Third is, which can do is, which ideally we should do, is that we should not have continuous questions for one construct. Say for example, we are checking, say we want to find out the impact of, say, financial literacy on the stock market participation. Now we might have five questions, five items for measuring the literacy. Rather than having those five together, what we can do is we can have one, and then we can have one from another construct, we can have one, the third from another construct. So you are mixing all, because you don't need to tell the respondent what you are measuring. But if you make these three things, in your questions, the sequencing of questions, one, that you, of course, you don't name at all that what you are measuring. Number two, that you have mix of scales, right? And number three, that the sequencing of the questions should not be construct wise. So this way you will be able to avoid common method bias, because it is related to method only. So there are methods that we can do it. So we can check it, and in that case the VIF should be less than 3.3. If it is less than 3.3, so we say fine, go ahead, there is no such bias. And if it is more than 3.3, and then in that case we will have to see and check about these methods. So this is advised to do at the time of pilot testing, because if you collect the complete data, and then there is no use of doing this common method bias. So it is advised that you do at the time of pilot testing only, so that you can then change the sequencing of the question. Maybe if still it is there, then you need to show it to expert. Maybe the question language is required to be changed. Okay, so I hope common method bias is clear, right? And what it does is, how do we do it ideally is that we have, what we do is we have, let's say, 5 constructs. This is collinearity, like we are checking the what we do is, in this case, let me talk a little bit about this method. That in case of common bias method, one of the techniques is that we take all the constructs, like we have 5 constructs, we treat them as independent variables, and we create a random variable. I'm sure you know how to create a random variable in Excel. You create a random variable and treat that random variable as the dependent variable, and all other would be the independent variables. So we run the regression, and when we run the regression, and then we find out this this VIF value, right? Collinearity value. If it is less than 3.3, that means there is less collinearity among these variables, actually the construct, so there is no problem. But if that is more, that is the essence of this value, that why this value should be less is because it is checking the collinearity among those variables. Okay. Now let's talk about now the measurement model, which I told you there are 2 methods, right? One is for the reflective measurement method, that is for the reflective model. I told you reflective model is that they're coming out of the construct. Now here we need to see first the loading, right? The loading of these should be at least 0.7, the more greater than 0.708. And there is one rule of thumb that if it is less than 0.4, you should simply remove it. You need to delete that particular item, right? Because that is not important then in that case. So, and if it is between 0.4 to 0.7, then you can calculate the average of all these, right? And if the average is more than 0.5, then go ahead with it. And if the average is coming less than 0.5, then you need to drop the lowest one. That is the criteria for this. And in case of reliability, I'm sure all of you have done this. You know, Cronbach alpha should be at least 0.6, right? We have other ways of doing it also. The maximum value of alpha, we usually say it's 0.95. Again, it depends on the type of this. We are talking about the humanities research. Of course, when we talk about the natural sciences, there obviously it would be much higher requirement. Okay, so the threshold is 0.6. Then we would check about the convergent validity. This was reliability. Now validity, we need to have average value of greater than equal to 0.5. Then only we will accept it. Then in case of discriminant validity, I'm sure you have done these tests, right? So the latest test is HTMT test, where it should be less than 0.9, and that is the acceptability for the discriminant validity. We'll discuss this in the papers. Now again, if you see now the formative one, as I told you, the formative construct is the one which where the items, they form the construct. So obviously we will not talk about there. We don't talk about alpha there, because we are actually not finding out the correlation. We don't expect they are correlated. So we will straight away go to convergent validity, and it should be at least 0.7 correlation. We'll discuss about the collinearity VIF, that it should be more than equal to 5. So we'll go to the papers and check it once. Let's go to one of the papers. Okay, now when we are through with the outer model, right, and then we'll move to the structural model. Structural model is all about constructs. Now again, in case of constructs, we will be checking the collinearity, right, and it should be VIF should be again greater than equal to 5. And if there is the collinearity value VIF is more than 3, so in that case we will see if the probability value, if it is significant, then we can go ahead. If not, then we will have to look into the issues. Then once we are through with each of the collinearity, then we will check for each construct, we'll check the R square, because R square has to be checked for each of the construct. Once we check R square, it will tell us about the how how good the model is. Not actually the complete model. We will check this R square for each construct, right? So after checking collinearity, we will check R square for each construct and also F square for each construct. Now R square, we all of us know that we have R square and adjusted R square. Now R square actually tells us that how much your model is explained. How much is your model explaining it? For example, if R square is coming out to be zero 0.8, so it means that you know your this model is explaining 80% of what you are trying to measure. So usually we say that R square should be higher, but then even if the R square is more than zero 0.3, also at times 0.2 also can be accepted in social sciences, because we know that there are a lot of factors which measure a particular thing. So it's not natural science where we can say that R square can be 95%, 99% also, but in case of social sciences, we say that R square can be accepted even at 0.3 also, 0.4 also, depending on what you are measuring. And there's a little bit difference between R square and adjusted R square. The problem with R square was that what people used to do, researchers used to do, is that when the R square was less, they used to add more constructs. So when they add more constructs, automatically the R square would increase. These items, the R square would increase. So for a particular construct, if you have 5, let's say, items, and R square is 0.4, and if you would add the one more item, there would, with even though overall reliability, overall there may not be overall change in the model, but R square would increase because R square has relationship with number of items also. Now that was some weakness. There's a weakness in R square, so that's why we have something called as adjusted R square. So adjusted R square takes care of the change in the value of R square just because of adding the item. So just because you are adding any item, R square would increase, but that biasness has been overcome in case of adjusted R square. So that is the reason that adjusted R square is always little less than the R square. So R square, whatever value it is, if R square is 0.6, so it means that 60% this model is explaining your problem. Now, close to R square, which is F square, which actually tells you it is though calculated based on R square only if you see the formula. So F square will give you actually how much that particular construct is measuring this particular model in total. So F square will tell you, let's say it is 0.9. So it says that out of all the constructs, this construct explains 90% of your model in totality, right? So it is more of, I would say, it's like the ranking one. Like, so it tells you, okay, which is the most important out of all the constructs. So that is what F square tells you. Now, as we know that R square will be calculated for all the different constructs. So now overall picture of the model would be given by the model fit test, right? So which is based on root mean square method. So we say that it should be ideally below 0.08 should be the model fit, and these days we accept up to 0.1 also. But model fit is actually for the entire model. R square we calculate for each construct. So this is calculated construct wise. So you will see the paper, every construct has different R square. And whereas model fit will talk about the complete entire model, combining all the constructs, what is the model fit. So this is root mean square error. This should be maximum point one, right? Uh, Root mean square is related to regression only if you know the line which fits the model. So we can have variance across that line, maximum of 10%. Earlier it was 8%, 0.08. Now it's acceptable is 10%. Now in the recent PLS, we have something called as PLS predict. So it talks about generalization of the model to the entire population. This we cannot test with other, like R square or model fit does not tell you that whether your model can be generalized to the complete population, the entire population. So to do that, whether let's say this model can be a fit in other economies also. Let's say we talk about India being a developed economies. If we have developed a model in India, and can we generalize it for all the developing economies? This can be only verified with this what we call PLS predict test. So we say that there is something called as Q square value which we get. What this does is ideally it breaks down your sample into smaller subsamples, ideally 10 samples of, let's say you have 100 sample size, right? And what it does is it divides your 100 sample into smaller, let's say 10 samples of each 10, and then what it does is it runs again the regression, and it runs this regression with the 10 samples only and keeps on doing it multiple times, right? And then finally comes up with a value which is, I don't want to go into mathematics of it, but which is called as Q square. So that Q square, if it is more than zero, it should not be zero. So if it is more than zero, it means that your model can be applicable to the population of the similar economies, right? So we, these days you will see papers, they having this predict value also, Q square value also in it. Okay. Now, another two important things which we need to understand before we move to the papers is, one is called as mediation, right? So mediation, what few things you need to know about mediation. For example, if you see this y1 to y2, this is direct, right? Y1 to m is direct. M to y2 is also direct, right? Now, if we want to find out the effect of y1 on y2, then this P3, that is the value which we get, is the direct effect, right? But then we need to find out if there is indirect effect of y1 on y2 through m. So m is a mediator, right? So this is mediation. So we will have loading, we'll get loading for P1, we'll get loading for P2 also. Simply to find out, the value is just multiply the factor loading of P1 into P1. So loading of P1 into P2, you will get the indirect effect. Clear? So if we wanted to find out the total effect, so we have direct effect, we have indirect. Direct effect is y1 to y2. Indirect effect is simply you are multiplying, because these are correlations, right? So they are coefficients. So coefficients of two, if you want to find out the sum of two, meaning the combined effect, so we multiply, we don't take sum. So P1 into P2 will give you the indirect effect, and P3 directly will give you direct effect. Total effect would be sum of these two. Okay. Now, very simple. If let's say in first case, if this is P1, this effect is, let's say, indirect effect in total is say significant. Significant would be you will go to the table and find out if it is less than 0.05 p value. If it is significant, we say that it has indirect effect. Otherwise, we'd say there is no mediation effect. Okay. Now, if here you see if the direct effect is significant, fine. So if both are significant, like P1 into P2, indirect effect is also significant and P3 is also significant. We say, so both have the effect. So it is partial. It is partial mediation, right? If, I repeat, if the direct effect is also significant and indirect effect is also significant. So we say both are significant, which means that, it is partial. So mediation is partial. But if the direct is not significant, only indirect is significant, so we say it is full mediation. It is full mediation. That's what it is mentioned, that if the direct effect is significant, then it is partial. And if it is not significant, then we say it is fully mediation effect. Okay. Now we can have this mediation effect multiple ways. Like we can have 2 ways of mediation effect also. So that also we can find out, right? So we call it serial mediation. If we have 2 ways mediation, we have direct. You see here, y1 is impacted, y2, y1 to y2 is direct. It is through m1 also, through m2 also, right? But for mediation, you need to understand one thing, that if there has to be direct relationship also. Are you getting it? So y1 to y2, if it is like y1 to m to y2, we won't call it mediation unless there is relationship between y1 and y2. There is direct relationship also. So mediation is only an, otherwise it will be called partial. But here, if y1 has direct relationship with y2, and then we will talk about mediation. Otherwise, not. Okay. Let's go to this first paper. Any questions till now?
Yeah, Professor Maroof will have the question answer towards the end.
Yes, yes. So I will just go through these
Thank you.
papers now. Okay.
Yeah, please go ahead. Please go ahead.
Now I have my hypothesis in this, and let's see the measurement model. Okay. Basic demographic features. You see here the first test. We have given the result of common method bias. As I said, it is important because we should do it at the time of pilot testing, that we check the Cock and Link method we use and find out the VIF, which is here not exceeding 3.3, right? So we go ahead with it. And I told you about how do we ensure that this biasness is not there, at least 3 different ways. So we're talking about measurement model. This is the reflective model. How do I know this is reflective model? I will go to the model, right? You see arrows are going, and okay. Now I will check the reliability and validity. Okay. So in this paper, you see the Cronbach alpha for almost all is factor loading is 0.7, Cronbach alpha is 0.7, 0.9. So no need to worry. Even the other ways of row A is also coming out to be high, right? We usually say it should be more than 0.7, so it is coming out fine. So that means that we can go ahead with the testing with this reliability is there. As I told you, if the factor loading, you should also see the factor loading. If it is less than 0.4, then in that case, you should straight away drop that variable, that item. Okay. Now for the validity of the constructs, right? So we are given the lower value, higher value. Okay, so what we do is we have to check that if it is more than 0.5, so in that case we say it is fine, right? So these you should be very careful about the factor loadings and the intervals, right? So what does interval mean is that point it the if we run samples multiple times, so any sample will have at least 0.751 as the value, right? This and the maximum value would be 0.881. So interval tells you about the minimum value and the maximum value. That's why we have intervals also here. Then we move to the model fit of the construct. And the R square, as I said, R square should be ID. I mean, if it is 0.6 or more, it's really good. 0.6, 0.7 is wonderful in social science. But even if it is 0.3, you can accept, but then you will have to justify it why the R square is less, why your model is explaining, is this model is able to explain only 30%. And it's possible. We have accepted papers where R square is even 0.3. The maximum for HTMT value maximum should be 0.9. Okay, and adjusted R square would always be little less than that. There is one thing which you need to be little careful about is that if there is huge difference between R square and adjusted R square, like we usually say that okay, fine, R square is 0.6, even if this is 0.5, it is fine. No, it's not fine. There has to be the difference between R square and adjusted R square has to be very, very less. Like it cannot be like 0.2 difference. Like for example, if it is 0.6 and this is 0.5, that means that there is something wrong with your construct. So you need to check the construct and the items, because otherwise there is some item which is actually probably not important or significant, or it is quite possible that you need to probably see if the items need to be again redefined, or probably the questions may be reframed, so you may consult the expert. But the difference should not be more than one means 10% difference. So it could be here, like if you see it is just hardly 1% difference, in between R square and adjusted R square. As I told you, R square would be like it will increase for sure if you are increasing one item. Whether that item makes sense or doesn't make sense, R square is going to increase. But adjusted R square will not increase. Okay, if it doesn't make sense. Now you see F square test. You see what does 0.94 mean? It means that brand admiration is explained by brand respect. 94% of the model is explained by the this for this construct is explained by brand respect. But that does not mean that CSR communication and enrichment benefits are not important. They may not be important for this particular construct, but for others they are important. Like you see here, it's 0 0.5, it's 0.36. So this F square test will majorly tell you that which is the most important of all the constructs. Okay. Then once we are through with checking the constructs, right? So this is all about checking the individual constructs. Then obviously we will check the model fit, right? And the model fit means that we are trying to find out what is the overall impact of this particular model. Okay, so we can check it through SRMR test. Again, this is nothing but this is root mean square residue of the residuals, right? I'm sure that in the regression we have that line of best fit, right? That line of best fit, around line of best fit, ideally all these constructs should be on line of best fit, right? What we call as the line of best fit in case of regression, in case of linear regression. So we say that all the points should be on that line. So all these constructs should be on line, but there will always be error. So square of those errors should be maximum. We say it should not be more than 10%. So that's how we calculate this root mean square value. Now that was all about the outer model, measurement model. Now if you look at the inner model between the constructs, so this is these are the different coefficients which we have, right, between the constructs. And what we simply see is we check their p-values, right? Coefficient is of course important, but ultimately it will depend on p-value. So if the p-value is less than 0.05, we say fine, this is significant, right? So it has the impact. And see, these are if you see these ones, what are these? Why do we have 3 here? What is BRES? This is mediation, right? This is mediation. Okay. So here we have H3, H3A. So look here, this is direct measurement, right? BRES to BADM, and then this is indirect, right? So we have mediation. Here we have 2 mediations, right? We just need to check if we want to find out if we want to see whether this mediation is significant or not, just go to p-value. So p-value is here, p-value is less than 0.05, so we say it is significant. So yes, there is mediation effect, right? And then you will check also the direct one. If the direct relation is there, that is also significant, so we say it is partial mediation, as I said. If the direct one is not significant, then we say that it is fully mediation effect. So all these more than 2 are all the mediation effects, right? So this is not significant. This is 0.3. So this is not significant. So not supported. This is not significant. So this is 0.07. So more than 0.05. We say it is not significant. This is also not significant. Right here we say direct relation. This is not significant. Same is mentioned in the model. Now, if you are writing a research paper, so obviously you should try to minimize these tables, because you have word limit also. But in case you are writing a thesis, so you may write these separately. Like you will write first, you will give the direct ones, and then you will give the mediation ones. So, but in case of research papers, it's advised that you make a comprehensive table of these. Okay. So, yes. So this is the more estimation results. Okay. So you have it's mentioned here the p-value also. So to mention that whether it is significant or not. Now, what is important in papers is that when you are writing, you will not only write that CSR communication has its value is significant, this is significant, that is not significant. No, you will have to interpret it, right? You will have to explain what does it mean. That is the essence of this. Like this paper, this model looks very simple. It is not very complicated model. It's very simple. So, and it doesn't have complicated mediations also. Moderation also not there. But there is novelty in the paper. That is the reason that this paper got published in Q2 journal. Now, it is not that the more complex you make a model and that model you will get published. It is important that whatever model you have, there has to be some novelty to it, maybe some new construct, maybe some newness in the form of new strategy which you have applied in this. Unless there is novelty, then it will not be published just because you make it very complex model. Okay. So we'll share this paper with you. It's a very simple paper, but just because of novelty, it got published in a very good journal. So predict is also value given here. You see. So if all of these are more than 0, like means that they are positive, you can always give this result. That is means that because we can generalize this. Okay. These are root mean square values. These are just the mean values. So root mean square values are given if the data is normal, right? If it is not normal, then in that case, we give the if the constructs, the sample is not normally distributed, then in that case we give LM values. Then you need to mention about practical implications of this. This is more of an academic paper. We'll just show you one paper which is more of it has more of value in terms of in practice. So there the implications have to be mentioned differently. Limitations, you should always mention. Limitation does not mean that you will mention that limitation of in terms of resources or other things. No, limitation is with respect to the methodology which you are using, right? So you will have to mention that what are the limitations of the methodology. This is one paper which is very simple. Then another paper where we have mix of the methods. Just one second. You see this particular, just one second. You may give the depending on the type of paper, you might mention the instrument also, right? The way we have mentioned in this particular paper. right? Then you will go to results directly, right? Like in this also we have mentioned the Cronbach alpha. So this is formative, so we won't talk about the reliability here, right? So straight away the redundancy coefficients. This is completely formative one, right? You see, they are making this construct. So we have not talked about here in case of this the. So in case of formative, as we said that we should try to not leave any of the item, right? Even if the loading is less. Whereas in case of the reflective, I told you that we need to find out that the loading should be at least 0.4. That is the difference, right? So we will have to see that even if it is less, it's fine, we can take it. You see here it is 0.1, 0.19 only, right? But we're not dropping this particular item. Reason is because it it is formative, so it contributes to the construct. So we won't talk about correlation among these variables, okay? These items. So these are the path coefficients. You see, we see whether they are significant or not. This is 0.29, so it is not significant. So R square is 0.4, adjusted R square is 0.422. So this has predictive power also, right? So Q square is 0.4, which is very good. Now I'm showing this paper only because of one reason. Okay, this. So there is something called as a very important map called which is called the performance map. Now this performance map will tell you, it has two ways, like one on one axis it has performance, other one it has the importance of that particular construct. Now if you look at these constructs, ideally all these constructs should be above this line, right? And on this particular quadrant, right? So this has high importance and high performance. So this is importance, highly important, and this is performance, high performance. Now this particular map, you can easily identify the particular construct which the researchers, the practitioners need to work on. Like supply chain management here, we found in this paper, is very important, but its performance is not good. So since this is more of the strategies, this paper is on the strategies which are followed by the farmers. So the farmers need to work on the supply chain management, because this is one of the important factors, important constructs, but its performance is not good. Okay, so this map will tell you which are the important ones or which are probably require high attention, right? So we'll send you this paper, you can go through it, and this also is from PLS only. I'm sure you have done this. Now you see, why I showed you this paper is because of the recommendations. This paper is more for the practitioners, right? So it has to be written different way. It cannot be written the way we write in case of academic. In the case of academics, we are more concerned about that, okay, what is the scope, what is the gap, right? And what are the limitations. Here, the recommendations, since this is for the farmers, so the recommendations would be aligned to the practitioners only, right? So the policymakers to make the policies and for the practitioners, like for the farmers. So that is why, you know, the recommendations are given, like training programs on organic farming practices, right? Organic certifications. This is based on, you know, this model, right? Adoption of the digital technology, right? Supporting the foreign producer organizations. So this would be majorly targeting the supply chain management and how we can make the supply chain management better. Because the model says that this is the area where, you know, the uh, the farmers need to work on. Okay, so whatever is your journal and whatever is your topic, it has to be accordingly as per the journal. You will write the recommendations, whether it's an academic journal or a journal which is for the practitioners. Okay, any concern till now? Yes, I tried to cover important things with the impression that, you know, you all have done, you have practiced these days the models. Any questions, any queries?
Yeah, Professor Maroof, is it over from
Yeah,
your side?
yes.
Okay. Researchers must bring novelty in model, rightly said, Professor. Uh, well, uh, Professor Maroof and dear participants, I sincerely apologize for the inconvenience caused earlier due to a serious internet breakdown. I have great respect and regard for Dr. Maroof and his rich credentials and to all the participants. Thank you, Professor, once again.
Okay, thank you so much.
Well, dear participants, the session is now open for questions and answers. Yeah, please. Uh, you can directly open your mic and ask the question, or else what you can do is you can drop it in the chat box. Yeah, is there any question? Is there any query? Yeah, Professor Maroof, I believe, I mean, you have been so much, uh, very much clear in your presentation. So everything is clear with them. But I want to, uh, I mean, based on my experience, I would like to hear just a little bit, regarding some of the common mistakes that beginners make while building SEM models and
Yeah,
how they can address.
I think, you know, Dr. Shahid, most important probably is the questionnaire. That is your main, I would say, uh, the center of everything is your questionnaire. Because if there is anything wrong with the questionnaire, you know, you might collect data, large data, 500, 700, also more than the sample size required. But if the questionnaire is not apt, then there will be problems. Like that's why if there is a problem with the questionnaire, your complete model is wrong. So it's important that researchers develop the questionnaire and do a lot of pilot testing. Like they should not hesitate in pilot testing. We have a problem that when we are doing PhD specifically, we rush into collecting data because we feel that once we collect data, then we will do the research analysis. But that is not the right approach. The literature should be done really well, and then the questionnaire should be tested, reliability should be tested, it should be shown to experts. There should not be hesitation, because if there is any problem with the statements, with the constructs and the reliability, then that will persist because that is structural problem, and if that persists, then there will be problem. Because now what happens these days is that people are more concerned about the beautification of the models using. I understand that is some of the journals might be fascinated by that, but good, I have shown you two papers. Believe me, will share with you. They're very simple papers, very simple. I mean,
Right.
hardly any difficulty. It looks like you can draw it with pencil and paper. But then they are accepted in Q2 journal just because of the novelty and the
Professor Maroof, I fully agree with you. I remember our good old days, Professor Firdos and myself. I believe more than 1 year we have devoted on the review of literature.
yes, so
That might be the
that is
same
important.
story with you.
That is important. That's important. Yes. Then you will be able to develop a better instrument, because instrument is very important questionnaire. And
True, true.
a lot of times we develop the questionnaire and we tell some information to the respondents also, which is not good. Respondents should not know anything about the study, what it is actually. Yes, in general, of course, that can be done, but not in the questions. So you should. That's why deliberately we have the questions which we repeat to check the biasness. There are questions which are mentioned deliberately in the opposite direction. Like we have negative and positive question, which is actually measuring same thing. So these, and we shuffle the questions.
True.
These ensure that the biasness is reduced. Because if biasness is not
Reduced.
there, your results would be robust.
True, true. Yeah, Professor Maroof, one more. Dr. Firdos, if time permits me, if you give permission, just one more, just it will take just few minutes time more.
Please go ahead.
Yeah, Professor Maroof, there is again a concern with the researchers. Where they find some problem related to mediation and moderation. Can you, in simple terms, give some insights? So that they develop good understanding related to that mediation and moderation.
Uh, it's like, for example, we say, let's say, me and Dr. Firdos, there is a conflict happening, right? And Dr. Shahid is mediator. So, can mediator be there if there is no direct relationship between me and Dr. Firdos? So Dr. Shahid as a mediator will be called only as a mediator if there is direct relationship between, when already there's a talk between me and Dr. Firdos, right? So mediation, it is in between, right? It could be a catalyst also, right? So there is one particular construct and there's another construct, and there is a mediator which may be there, that may have impact, that may not have impact, positive and also negative, both, right? And the moderation is like, it is more of, I would say, it is like, for example, it is either strengthening the relationship. If you see in terms of the arrows, like A, B, C, the moderator will go from A to B to C, right? Whereas when it comes to the moderation, it will be on that particular arrow. Are you getting it? Like A to B, and in between that, if you see the direction, I think there was on paper. Let me just show you it so that it's like clear. Give me 1 second.
All right, Professor, please.
I just want to share the screen. Uh, is this photograph visible? This pic?
Yeah, Professor, it is visible, please.
Okay.
Yeah, thank you.
You see this dotted line?
Right.
This is moderation, right?
Mm,
Whereas this is mediation, like from this to this to this, right?
right.
But there is no direct, so we cannot say this is mediation. So there has to be some direct relationship between these. So if I have to find out it, like for example, where do I have one direct? Through this. Okay. So mediation is, I will show you some other model for this. So mediation is that there is no relationship between these three. It's not a triangle, right? It's not a triangle,
Mm,
right? So in case of moderation, it is just it may impact this relationship. Fine? Are you getting it?
right.
For
Right,
for
right,
example,
Professor.
for example, you remember we had very high switch costs earlier when we had these few telecommunications. Like these days, it's very easy to switch from one company to another company. You don't have to change your mobile number, also nothing. Like give a call, your number would be ported, and you will get the different service provider, right? So cost of switching is not there. Whereas if you look 10, 15 years back, if you wanted to shift from, let's say, Airtel to BSNL, or let's say Airtel to Vodafone, you would require a new SIM, you would require a lot of processes. So there was a lot of switching cost. So that switching cost was a moderator, right? So
Mm,
moderator does not have a direct relationship between these two variables. Whereas mediation has relationship. You see mediation?
right, Professor.
Just 1 second. You see, this is mediation. Now, mediation there is direct relationship between the mediator, right?
Right.
Y1 to Y2, it is from Y1 to M, then from M to Y. So there is a relationship between these. Whereas
Right,
if it is the moderation, it will be directly on this line, you see? So it is
right.
impacting the relationship. There is no relationship between these two factors with with the moderator. So moderator does not have any relationship between two factors, whereas mediator has relationship between both. And if that
Right.
relationship is significant, like if we say P1 into P2, not P1, P2 individually, P1 into P2 is significant, we say that mediation is there. Now if that whether that mediation is full or partial will depend on P3. So if this P3 is significant, we say that direct relationship also significant, and through mediation also it is significant. So it is partial mediation. But if the mediation P3 is weak, like it is not significant, so we say it is full mediation. So it is through this relationship only. Whereas moderation will not have the relationship between these two. Like the way we have the switch cost. Like switch cost does not have any relationship between the service quality, right? Satisfaction. But since earlier the switch cost was very high, so it was impacting the relationship between Y1 and Y2.
Correct. Thank you, Professor, to bring more clarity on this. Thank you once again. Well, uh, again, towards the end, thank you, Dr. Maroof, for delivering an insightful and enriching session. Well, your detailed explanations and paper in hand, I mean, it has undoubtedly enhanced the participants' understanding and confidence in applying these techniques to their own research. I would also like to extend my appreciation to all the participants for their active engagement. Well, uh, I mean, their participation has truly added value to the academic learning and make these workshops productive for everyone. Well, a special thanks to the JK Economic Association led by Professor Firdos Malik for organizing this comprehensive series and for providing a platform that brings together scholars, professors, researchers, and experts from across regions. Over to Professor Firdos.
Thank you very much. I want to share, appreciation of gratitude to both our moderator and our resource person. Let's first start with our resource person, Dr. Maroof. So we are very much thankful for accepting the call at very short notice and enlighten us with the applied of STEM model and other tools and techniques. So on behalf of Jammu and Kashmir Economic Association, we share our gratitude appreciation in the form of this certificate. Now I would like to follow up for our moderator, Dr. Shahid. So we also, appreciate the acceptance of the call and providing us your time at very short notice and running the session smoothly. So thank you very much for both. Now I would go to for formal vote of thanks as we are concluding today's session. This was all for the personal appreciation on behalf of Jammu and Kashmir Economic Association. So I would like to take few minutes to share my appreciation. So dear friends and participants, it is indeed an honor and my privilege to deliver vote of thanks on behalf of Jammu and Kashmir Economic Association, Global Research Foundation, Crescent, B.S. Abdul Rahman Crescent Institute of Technology Chennai, Crick University, Deep Skills, and our Journal of Humanities. So as we conclude today's session, this was one of the enriching sessions of the 7-day international workshop on applied SEM, model building, reporting and interpretation. For the past week, we have had the wonderful opportunity to deal deep into the world of structural equation modeling, which has been guided by eminent experts, resource persons, and supported by the engaging community in the form of participants, all of you. So again, on behalf of Jammu and Kashmir Economic Association, I would like to extend my heartfelt gratitude to our distinguished resource person, Dr. Maroof, who is serving as Professor and Dean Academic Association School of Business, and also to Dr. Shahid Amin, Associate Professor, Department of Management, Institute of Technology and Management, Gwalior, Madhya Pradesh. So today's engagement, scholarly insights, and the way practical demonstration Dr. Maroof and his engaging session have not only enhanced our understanding of SEM, but also inspire us to apply these techniques meaningfully. Especially, he has more focused with greater concentration that how we have to report our model, how we have to report our results. So these techniques meaningfully in our future. Research and academic pursuit will definitely help me as a learner, and I am sure that all participants have gained with this. So a special word of thanks and appreciation, for all the moderators, all the resource persons for sharing their exceptional coordination and academic leadership throughout this workshop, and their ability to help us to connect theoretical concepts with practical applications made the session both rigorous and accessible. We also acknowledge the sincere efforts of all the participants who participated one way or other way, and our technical support in Jammu and Kashmir Economic Association and other contributing collaborators across the world who have shown interest for organizing this workshop. So in the end, I would like to appreciate your enthusiasm, your active engagement at participants who have made this workshop intellectually stimulating experience. So as we conclude this 7 days workshop, It was a 7 day journey of learning, and there was greater discovery. I thought at the beginning, although I am a good research in the field of economics, but learning new software SEM, I was having very narrow knowledge about that SEM. They may be running the model and all. But today, by organizing this wonderful workshop and having interaction with rich, eminent galaxy of scholars, it has opened my mind that SEM again, SEM methodology, SEM technology, and research based on SEM modeling is just like SC. So there is no end. So therefore, these 7 days have journey of learning which has discovered. So let us carry forward these insights which we have gained together and continue to build a strong culture of research excellence and collaboration. Thank you once again for your participation and contribution. So I am now,